We've got a full schedule this year, and but our welcome to this class, Holland Response to Our Climate Crisis. And I'd like to welcome our speakers today. Peter Bogart has spent the last 12 years working in the field of residential energy efficiency. He was employed by the Ottawa County and certified by both the state of Michigan in its weatherization assistance program and nationally in Building Performance Institute. In 2016, Peter was hired by the city of Holland to launch its home energy retrofit program. He is the core leaders group for the lobby efforts. I've lost my place here. He is the core leaders group for the Holland chapter of Citizens Climate Lobby, where he leads the lobby efforts for our members of Congress. He's been a local leader in the caring for creation movement since 2001. A graduate of Calvin College, he also has an MRE, Master's of Religion Education from Western Theological Seminary. And also with us, we have Don Triesenberg. He is a scientist, teacher, and a community volunteer. His career includes 20 years as an administrator for the American University in Washington, D.C., and 16 years as a high school social science and math teacher. Since his retirement, he has served on several West Michigan boards and commitment related to environmental issues. Participates in the Holland Climate Change Collaborative and works with Hope College in developing air quality monitors for middle school and high school students. He is a graduate of Calvin College, now University, and earned his PhD in physics from the University of Maryland. So welcome to both of you. Jim?
Thank you, Mike. And thank you to everyone for taking time this afternoon to be with us and to listen to this presentation. We're really grateful for the opportunity to be speaking with you all. Give me just a moment. I'm going to share screen here. We've entitled this presentation, Holland Responds to Our Climate Crisis. And we will be taking a look at a sort of high-level notion of climate and the climate crisis. And then we're going to get rather specific in terms of Holland and how Holland responds to that crisis. But that's the time we're going to spend together. Don and I have planned this week. I'll do a lot of the presenting this week. Don will kind of take the lead next week, Monday, when we take a serious look at Holland's community energy plan, where it is at the moment and where we believe it ought to be going in the future. And again, my name is Peter Bogart. Mike introduced me as a member of Citizens Climate Lobby. I wanted to kind of highlight the creation care aspect. That's really the reason why I'm here. In 2001, I was asked to be a Caring for Creation coordinator at Hope Church in Holland. I knew nothing about that at the time, but for some unknown reason, I said yes, and have been learning about environment and faith and the conversation between the two ever since. And it is the reason why I stay in this conversation. You know, we'll be very specific about energy kind of policy and issues today, but I'm grounded in that conversation by a faith commitment that this is our Creator's world and we have responsibilities for how well we live in this world. My immediate background has all been in home energy retrofit and energy efficiency kind of issues. So I was the guy who would go to someone's home, do the testing and the analyzing of the house, and put together a plan for how to make that house more energy efficient. And that's the background. That's the background I brought to the City of Holland when we launched the home energy retrofit program there. Don, if you would say a word about yourself.
Thank you, Peter. I'm nervous because Peter set such a high standard this week, and I have to try to follow that next week, but I'll do the best I can. I think the quick introduction I'd like to make of myself is to simply say, if I'm asked to describe myself, I would say I'm a person of faith. I'm a scientist, a physicist. I'm an educator. I'm a community organizer, and I'm a grandfather. All five of those things compel me to do what I can to convince our community to make a constructive engagement.
Okay, thank you, Don. This is an outline of how we intend to spend our time together. Don and I will present our goal for this session. We think it's important to get that up front and right out there at the beginning. Then we're going to take a look at climate science, to take a look at what that really is. We're going to take a look then at climate change. How did that become the prominent topic that it is today? How did that emerge into public consciousness? We'll kind of move down from that high level to the Community Energy Plan. Most people call it the CEP, which is Holland's plan for its energy future. We'll take a look at the backstory that brought that into being. We'll take a look at, flip the cover on that report and take a look at what's inside it. And then most of this will probably take place next week, but we'll take a look at where can the community energy plan go from here. And then we'll also pivot and ask, where do all of you fit in that kind of a process? One of the issues that Don and I really hope we can bring home today is the importance of your voice and your telling stories and your speaking to your representatives. We're very convinced that there needs to be change in the way we deal as a community with climate, but change isn't coming unless the community speaks. So we're hoping to give you the kind of material you need in order to be able to speak to your representatives. We're going to put our cards on the table. There are four factors that we believe are critical, that we accept, and that are the foundation for the way we think about these things. Number one, science matters. That doesn't seem to be uniformly the case today, but for us, very clearly science matters and we have to pay attention. We accept the fact that the climate crisis is real. There's adequate scientific evidence for that. It's not welcome news, but the climate crisis is definitely very real. We believe that public policy matters, that there are things we can do individually which are virtuous and will help to mitigate our demands for energy, will help to take down our carbon footprint. But ultimately, the key factor that has to change is public policy. And we believe advocacy works. That's my saying to you. We hope that you have enough material to work with at the end of this presentation that allows you to feel comfortable enough to call a representative and say, I believe climate change is real, and I believe our community needs to do something about it. So our goal in the end is for all of you to become informed citizens who take your place as advocates and tell your stories. I, on behalf of Citizens Climate Lobby, have been in Washington, D.C. on at least 2 occasions and calling on members of Congress in their offices on Capitol Hill. And one of the things we learned from those experiences is that your facts are okay, but everybody's got their experts. Everybody's got their set of facts and thinks that that's the definitive reason why Mr. Representative ought to do what you're asking. The reality is the people in the office are human beings, we're human beings, and we communicate best by telling stories. People are moved by what you tell from your own life. And so when we visit those congressional offices, we're always ready with stories that we talk about what's happening in the district, how it impacts our lives, how it impacts the lives of our children. And those are the kind of things that they actually remember, more so than all the facts and figures. I have learned the hard way that not everybody knows what climate science is. So I wanted to spend just a minute on that to make sure we're all grounded in the same set of facts. And we have here just a cave wall drawing of how it works. We have the sun and the radiation that comes from the sun to the earth. The sun puts out extremely intense energy, and it leaves the surface of the sun, because it's so intense, as shortwave radiation. Some of that radiation heads towards the earth, and some of it will go into the atmosphere, but encounters something in the atmosphere that makes it bounce back off and back out into space. So there's going to be a molecule of some kind of element in the atmosphere that will do that, and that radiation will never reach the earth. Other radiation gets through the atmosphere, but lands on the polar cap, the ice caps. And those ice caps, because they're white, tend to reflect radiation like a mirror reflects sunlight. And that radiation gets bounced back out into space and doesn't really affect the warming of the earth. Much of that radiation comes through our atmosphere, comes to the earth, and because of the energy transfer that takes place there, the earth is warmed by that addition of energy. Earth then does what physics demands, and physics demands and the natural world demands leveling out, that there be an even distribution of anything across the entire platform. And because the earth is warmer than space around it, nature says, well, we've got to even this out. And so some of that energy on earth gets radiated back out into space. Some of that radiation, however, encounters something in the atmosphere that bounces it back. And this is the so-called greenhouse effect. Typically, you're going to hear that conversation allude to carbon dioxide. And that's the connection to fossil fuels. One of the primary byproducts of combusting fossil fuels is carbon dioxide. So those molecules of carbon dioxide occasionally intercept one of those rays, they hold it in, and that keeps the earth warmer than it otherwise would have been. This is the point at which you all should be saying hip, hip, hooray, because if that heat was not retained, the earth would be a frozen snowball, and life as we know it would not be possible here. So greenhouse effect is a good thing. It's the reason we can live the kind of lives we do on the earth. A good deal of that radiation gets through the atmosphere, however, and back out into space. At that point, it's what they call long wave radiation. Most of you have heard the term infrared. This is infrared radiation. So the earth is shedding this heat, some of it is retained. The issue when we speak about climate change involves the composition of the atmosphere. Carbon dioxide by volume is the most abundant molecule in the atmosphere, and therefore the most significant at retaining heat. In our so-called modern era, other elements are becoming equally important. Methane is one of them. A lot of it leaks from pipelines and gas wells. There's methane frozen in the tundra, in Siberia, and in the ocean floor. And as the earth warms and those areas of the globe soften, some of that methane is also being released. Now, the concentration level isn't the same as carbon dioxide, but the concern is that methane is several factors of magnitude better at retaining heat than carbon dioxide is. The same is true for fluorocarbons. Those are escapees from our refrigeration systems, and nitric oxide, which is another combustion byproduct from industrial processes. So all those things are active. The more of it there is out there, the more effective they are at warming the planet. That's the greenhouse effect. But that's in a nutshell. When we talk about climate change, that's what we're talking about. This additional content in the atmosphere that retains more heat than otherwise would have been there. Here's a slide you may remember from Travis Williams' presentation. This comes from NASA, and it shows the carbon dioxide concentrations in the atmosphere for the last 800,000 years. What I'd like you to note is the sort of sawtooth configuration of the graph, high points and low points. And roughly every 100,000 years, there's a circulation between a high point and a low point. The high points on that chart are the Earth as we know it. This is human history occurred at this point in the cycle. And the low points are the points where the Earth would have been experiencing glacial experience. It was much colder. And so depending on the concentration level of carbon dioxide, the Earth has oscillated or had changing climate on about 100,000 year cycle between temperate times and cold times. And that's all kind of related to the tilt of the Earth on its axis. There's a little bit of wobble in the Earth's rotation. And then the Earth follows the sun in an elliptical cycle. So all these subtle changes over time have changed what the atmospheric uptake of carbon dioxide is or isn't. So when we get to climate change again, we're talking about basically that period of time that starts around 1750 for the Industrial Revolution. At that point in time, there were about 280 parts per million of carbon dioxide in the atmosphere. We were at kind of the peak in the cycle, the kind of warm world that human beings like. In 1950, we would have been around 300. And still, that's quite near what the historic peak has been. What's concerning to us is that now in 2020, the carbon dioxide level is up to about 417. And what you see is the chart isn't heading down, it's skyrocketing up. And the concentration level of carbon dioxide alone in the atmosphere is at a level which hasn't been seen for at least 1 million years. That leads us to believe something's got to change. And it probably is not going to be the kind of change that helps human life on Earth. Here's a shout out to Charles Keeling. He is the man who first began to pull together all this atmospheric data. In 1958, he went to Hawaii to Mauna Loa Observatory on behalf of the Scripps Institute, and he began to chart what the atmospheric concentration level of CO2 was. They went to Hawaii because they felt that was the cleanest air they could find, that wouldn't be immediately influenced by any local industry. And you'll see his chart there from 1958 through 2010, and it's just totally ascending. And since that period of time, the concentration level is just steadily rising. If we could extend that chart to today, you'll see it has never stopped rising. There's a little oscillation in the chart where you see that kind of up and down motion, and that correlates with seasons. In the summer seasons, when the plants are active and trees are growing, they take more carbon dioxide out of the air. So the concentration level falls during that season. And then when the fall and winter seasons come on, the concentration level kind of goes back up. Climate science could be a whole career. And most of us are not going to be able to follow the math, the calculations, the equations, the studies, and all of that sort of thing the way the people who are professionals do. What I'd like you to understand is that you don't have to. The person you see on the screen is Dr. Catherine Hayhoe. Dr. Hayhoe is at Texas Tech University. She is one of the leading premier world climate scientists. She is also an evangelical Christian, which gives her a very unique perspective on what's going on in the world and what to do about it. But she breaks it down to this simple understanding. You don't have to understand all the math. You don't have to be able to do equations. But you do need to know, in terms of climate crisis, it's real, it's us, it's here, it's bad, it is getting worse, but our choices can and do make a difference. So act now. If you remember only that, that will give you the adequate understanding of climate science and what you need to know. If you want to dig a little deeper, and I encourage that, Dr. Hayhoe has a series of short video pieces. Most of them are animated, which makes them kind of fun. But almost any question you want to ask on climate science, she has a video on that. And you can go to her website there at Global Weirding and dial up almost any question you want and get her to answer that question. She says today, the single most requested video is, what does the Bible have to say about climate science? Climate science is an old study. I know we get a lot of publicity these days. Media has picked up this topic. Pundits on one side or the other are back and forth about climate and what to do about it or not. What I'd like you to understand is this isn't a new phenomenon. This study has been in process since at least the 1820s. Pictured on the screen there is Joseph Fournier, a French mathematician and physicist. He's the person who first seemed to realize that the sun warming the earth and heat being retained was a function of the natural world. And he began to pilot this notion of greenhouse. And so in 1820, this topic was already being studied and written up in journals. Now, a little bit of perspective for you. Michigan didn't even become a state until 1837. So this topic has been in conversation longer than Michigan has even been a state. Fast forward about 40 years, and John Tyndall begins to study exactly what kind of gases are in the atmosphere that make it retain this heat. He's familiar with the earlier work on greenhouse effect, but he wants to know more in detail, what are the mechanics? What makes it tick? And so he begins to identify the gases. And like I said earlier, today we really focus primarily on carbon dioxide. Fast forward another 40 years, and Swedish chemist Arrhenius has begun to understand that the concentration level of CO2 in the atmosphere has got something to do with the periods in Earth's history when there may have been glaciers. And he begins to understand that as the concentration level fell, the Earth got colder. and it got colder to the point where glaciers could begin to form and move south. Some of you are aware of the fact that something like 13,000 years ago, even the state of Michigan was covered by a glacier. But Arrhenius was the first person to begin to articulate this and understand how these concentration levels within the atmosphere actually impacted the physical world that we live in. There's a sort of parallel discussion that's ongoing. And I think for some of you, I may be taking you down a trip down memory lane here. But the general environment itself started to become a conversation as people began to recognize the way we live within the world impacts the physical world. John Muir was one of the people who first started to articulate that conversation in this country. And he and others in 1892 founded the Sierra Club, understanding that we were losing the natural world as it had been created and experienced for most of Earth's history. And he was very active in trying to preserve natural areas. It's pictured on the picture there with his buddy Teddy Roosevelt, who was quite active as an outdoorsman, was active in getting national parks legislation put in place. Roosevelt had a real sort of spiritual understanding of manliness in outdoor life. And real men had to be really tested by being out in the real wild world. And so he was one of those voices too that was saying, we're losing something that's important to us. What do we got to do to preserve it? So this kind of a conversation was beginning to rise already in the late 1890s. If I switch back now to that energy climate kind of conversation, in the 1930s, Guy Callender began to notice that warming began to significantly increase on the heels of the Industrial Revolution. And this is maybe the first step forward in the conversation that we're part of today. It was one thing to note how the natural world works with concentration levels in the atmosphere. Stewart began to recognize, well, we're doing something to those concentration levels. And based on what we're doing, we're experiencing a different kind of physical world. So that's in the 1930s already. So almost 90 years ago, this conversation you could see really beginning to mature in the scientific community and again in the popular world. Callender's conversation, as we know it in the United States, really came into full flower in 1988 when James Hansen, in his congressional testimony, really laid out the linkage between the burning of fossil fuels, the increase in concentration levels of carbon dioxide, and the impacts that that change was making on the physical world. And he began to call out that note of danger, that we were on a trajectory which is not going to be healthy for human living or for life on Earth. So again, at least 30 years, this topic has been on the table and in the public realm. What I'm hoping you're seeing is that what we're experiencing today isn't a product of the last political cycle. It isn't a product of most recent years. This has really been coming to us for a long period of time. In the more environmental realm, again, as our when we use that term, the environment or environmentalists, one of the real grandfathers of the environmental movements in this country was Aldo Leopold, who originally worked for the United States Forestry Service. And his observation of the natural world from his work led him to understand that the way we as human beings engage with the world has a negative impact on that world. And he saw the trend lines as being unsustainable. He's kind of famous for saying a thing is right when it tends to preserve the integrity, stability, and beauty of the biotic community, but it's wrong when it tends otherwise. And so he began somewhat like, I think you see the John Muir conversation beginning to mature here. It isn't just preserve chunks of the natural world because they're beautiful, but we need to preserve the integrity of the natural world because that's what maintains our lives together, this whole interrelationship of one biotic community with another. Rachel Carson in 1962, when she published Silent Spring, really brought this whole conversation home. Not only are we doing things to the natural world, but she really focused on what we, through our use of chemicals, are doing to the natural world. And she called out the danger of the trajectory we were on, allowing chemicals to be used in such random fashion throughout the world. It's rather well understood now that I could take any one of you in the audience at random, get you a blood test, and we would find somewhere in the neighborhood of 200, maybe 250 artificial chemicals in your body. The problem is we don't know necessarily what the effect of that cocktail of chemicals is doing to us as human beings. We know what specific chemicals do, and DDT was the chemical culprit during Rachel Carson's time. We knew specifically it was doing great damage to the natural world, especially to birds and to insects. But what we're trying to get a grasp on today, beyond what Rachel Carson understood, was what is this small level cocktail of chemicals doing in our own bodies today? Okay, but again, she pointed out, but man is a part of nature, and his war against nature is inevitably a war against himself. So again, she really matured that concept. What we do in the world is going to impact our ability to live in the world. On the political front, climate change, we saw growing in the scientific literature, growing in the public mind. The very first time that climate change is called out in a public document in the political realm in this country is 1965. Lyndon Johnson was president, and he received the report Restoring the Quality of Our Environment. That was very much a report on what we traditionally think of as environment. But in Appendix Y4, for the very first time in public and in print, was this reference to atmospheric carbon dioxide. And so this is the point at which the discussion starts to move into the political realm, 1965. So what is that? 55 years ago, we began our political discussion, which is coming to something of a head today. What helped bring all this to a crisis in the environmental world were certain disasters that were being experienced. What Rachel Carson put forth in theory and in data became observable and undeniable. You're seeing a picture there on the screen from Los Angeles in 1948, and the smog is so bad you can barely see the buildings. This country lived with that kind of reality for a long time. I can remember flying into Newark Airport in 1971 and seeing this black line over the city, and that was the pollution hanging in the air. What really started to galvanize the public mind was the Santa Barbara oil spill in 1969, when raw crude oil began to wash up on the beaches in California after the disaster at that offshore drilling platform. You know, it's It's one thing to have people telling you something isn't right. Oil washing up on the shore is just undeniable. And it really shocked public consciousness at the time. And to take it up a notch, what really shocked public consciousness was in 1969 when Ohio's Cuyahoga River caught on fire. And the public realized, how bad can it be when water is on fire? Pollution has got to be really bad. And so these events just kind of crystallized for people the depth and seriousness of the problem and the need to do something about it. So action did begin to take course. You may recognize the person in the picture there. I'll give you a second. And that's Senator William Proxmire from Wisconsin. He was the person who led the formation of the very first Earth Day. President Nixon signed a lot of legislation that was designed to make the environment better. President Johnson was already active. Clean Air Act in 1963. Wilderness Act in 1964. And the EPA was founded in 1970. And there's Earth Day with Senator Proxmire in 1970 also. And then President Nixon signing the Clean Water Act, 1972. Endangered Species Act in 1973. And then President Carter with a Superfund, which was put in place in 1980. What we saw was this growing awareness of a problem with the way human beings live in the world, coming to a point where the problem was undeniable, and then response. And all of these responses did lead to a much better, more livable world. Back on the energy front, we were flirting with things to do and beginning to move that conversation forward too. Some of you are going to remember President Jimmy Carter in 1979 put solar panels on the roof of the White House. Those were not photovoltaic cells. Those were hot water cells. And tubing ran through there with water. And the water was warmed. And I think they used it for the swimming pool. President Reagan came in right behind him and had those panels removed. The story was that they leaked and they had to be taken down. But the panels aren't gone. In 2002, President George W. Bush put photovoltaic cells on some of the outbuildings around the White House, and he used the energy to heat the swimming pool. So our leaders are continuing to flirt with this idea of what does our energy future look like. Some of you are going to remember too that in 2006, President George W. Bush used that famous phrase, America's addicted to oil. And he began to raise a level of consciousness about fuels, what fuels we use, how we use them. And that began a thought process in this country that has continued on. I don't believe his intention was energy efficiency. I think it was more security. But nevertheless, he put on the public docket this discussion about fuels and how they ought to be used. In 2010, President Barack Obama installed a major array of photocells on the White House and used it to energize the West Wing. And I think they got 80% of the electricity they needed for the West Wing from those photocells. And just as happened sort of in the general environmental movements, there were disasters that crystallized the debate for people. The same thing is happening with climate change. And so there's certain disasters happening around the world. Flooding is one of them. That's maybe really pertinent today with the hurricane that's come ashore in Alabama and Florida. We're watching glaciers disappear. Here's a picture of a glacier from 1913 to 2012. So in almost 100 years, all the ice is gone. It has melted. Here's a chart that shows what some of the threats we face for sea level rise and what kind of parts of the country and shoreline are going to be impacted by that rising sea level. Agriculture is going to face serious issues in the realm of climate change. People who used to grow crops in certain areas of the world are not going to be able to do that anymore. We're going to experience more droughts in certain parts of the world. Those are already occurring. We're going to experience a real change in the water cycle. Warmer air evaporates more water from the surface, holds more water in the atmosphere, so that when it does rain, we have heavier rain events. And those heavy rain events are significant for the obvious flooding, but they're equally significant for the amount of erosion that they cause. When we erode our farmland, we diminish our ability to grow crops. And there are some studies out there that say we are maybe in the neighborhood of 30 to 60 years of topsoil left. If it continues to erode, we will have called seriously into question our ability to engage in agriculture as we know it. And finally, just hot. You may recall, I think it was 2011, there was a super heat event in France. A lot of people died in Paris. A couple years after that, a superheat event in Chicago, and many people died in Chicago. When the temperature reaches a certain point, human bodies just cannot function. And so you take all of these sorts of things together and you begin to understand that there's a level of disaster on the horizon beginning to arrive, and it's calling into question our response. What do we do? Here's some more information that helps us understand what's going on with climate change. Again, here's another report that you saw Travis Williams allude to in his report. This is an assessment of the impacts of climate change on the Great Lakes. It comes from the Environmental Law and Policy Center. And so they have pulled together all of the research that has to do with anything related to climate change in the Great Lakes region. And they are concluding that number one, we don't have to wait for climate change. It's already happening here. The North American continent, since about 1960, has had an increase of warm days, about we're about 4% warmer today than we were back in the 1960s. What's unique in that data is that in the Great Lakes region, we are 10% warmer than the North American continent was all those years ago. So we are on the leading edge of this warming experience. They predict, likely to see increases in precipitation and the flooding that accompanies that. We're going to see a curtailing of Midwestern agricultural production. They expect that crops like corn and soybeans are going to move north, especially in places like Southern Illinois, Southern Indiana. It may be just too hot and dry anymore. We're going to see, we're anticipating an increase in extremely warm days above 90 degrees. And there are a lot of factors involved in this. It depends on where you are in the Great Lakes region. And it also depends on what we do as a global community to minimize future introductions of climate warming gases into the atmosphere. So depending on what those combinations are, we in the Great Lakes region can expect to see anywhere from 17 to 60 more days per year of 90 degrees plus. We can expect wetter winters and springs and less summer rain. You may recall last year, this combination of events was really bad for agriculture. Farmers were getting their tractors stuck in the fields. It was just too wet. But the implication in terms of food production is significant for the Great Lakes region if we have to deal with this. We're going to see a decrease in cold days, less than 32 degrees. Part of me says hip, hip, hooray when I hear that. But you have to understand the natural world needs that cycle. And one of the effects may be more heavy lake effect snowfalls. We may see an increased risk for heat-related illness, and death. Again, and speaking specifically just for the Great Lakes region. And the other thing that'll be bothersome is an increase in algae blooms. So if you recall, was it 5-6 years ago, the city of Toledo had to shut down their water system because of that toxic algae bloom in Lake Erie. We potentially are going to see an increase in that kind of activity in the entire Great Lakes region. So in terms of this rising awareness that I hope, if we can understand it, helps catalyze our moves and call to action. These documents that talk about what's going on here come from the United Nations. You're seeing on there their 2018 emissions gap report. And on the left-hand side, the fourth National Climate Assessment. The United States government requires that all of our scientific government scientists, every 3 or 4 years, I think, put out a report on what's happening with climate. And they summarize all of their studies into a report that allows Congress to have material to work with. This is the fourth National Assessment, Volume 2, which some of you may recall came out this year, the day after Thanksgiving. I guess it was last year, the day after Thanksgiving. There was sort of a political move there, hoping you wouldn't notice being kind of distracted by the holiday. The report that most people are talking about when they talk about rising climate awareness comes from the Intergovernmental Panel on Climate Change. This report was out in October of 2018, and it's suggesting that what do we got to do as humanity if we're going to hold this global warming change to less than 1.5 degrees C total global average. And they began to examine that and talk about what to do. And they say we need radical and rapid change. I feel like the fellow on the right there, when I hear that radical and rapid, that, oh my goodness, how can you possibly even do that? The report shows, however, that the reason they stage it in those terms is this is where that phrase, we may have 10 years left, comes from. They're suggesting that we need to accomplish these tasks within the next 10 years if we're going to be able to hold the temperature change to what we think is a reasonable level to avoid the worst impacts of climate change. Here's another report. This is the 2019 emissions gap report from the United Nations. This is a report that analyzes where should we be in reducing carbon emissions compared to where are we. And there's two reasons why I put this report in front of you. One is to make clear the stark reality of what we're dealing with, but also to understand that this isn't a doomsday scenario either. So this report says the summary findings are bleak. Countries collectively failed to stop the growth of global greenhouse gas emissions, meaning that deeper and faster cuts are now required. If we had started when President Johnson was in office, we would be making small incremental changes now, but we have forfeited that time for adjustment. Now we need to make rapid and deep changes. The report goes on to say, and this is why I highlight it, however, behind the grim headlines, a more differentiated message emerges from the 10-year summary. A number of encouraging developments have taken place, and the political focus on the climate crisis is growing in several countries, with voters and protesters, particularly youth, are making it clear that it is their #1 issue. In addition, the technologies for rapid and cost-effective emission reductions have improved significantly. That last phrase is even more true today than when they published. It is now clear that alternative energy sources, in terms of power plants, are now cheaper to install than even natural gas plants. Coal plants are off the charts. They're not affordable. They can't even compete with natural gas, much less with the new alternative energies. But most people are now turning to the alternative energies, wind and solar, because they're actually cheaper than a brand new natural gas plant in a lot of places. They're actually cheaper than continuing to operate an existing coal-fired power plant. That's how rapidly things are changing. And that's really where a lot of the hope and comes for our ability to make the so-called rapid and deep change. Paul Hawken is an author, entrepreneur, businessman. He has a book out called Drawdown. And so there he lists 100 things we can do. What we need to do is not a mystery. It is well understood. The question is whether or not we're going to do it. So I thought before I move on here, this may be a good point to take a check and see if there's questions in chat or something from what I've been saying that you'd like to follow up on.
Okay, Peter, at the moment I don't see anything, but if anybody has comment or question right now, it would be a good time to type it in.
Let me just give a minute here for Paul Hawken. I first read Paul Hawken. He has a book out called The Ecology of Commerce. And it was in that book that I discovered the importance of attitudes. He talks about, for instance, if you're the manager of a power plant and you walk in the morning, you sit down at your desk and you ask yourself, who am I and what do I do? And if the answer is, I buy coal, burn it, and create electricity so that my community can have the electricity it needs, that understanding of yourself and your job leads to a certain set of decisions. Certain options are either on or off the table, depending on what you think your job is. On the other hand, if you say to yourself, I'm a member of this community, and it's my job to see to it that my neighbors live in comfort, then a whole nother set of options opens up. And you may be more likely to say, well, you know, I need to spend some time on energy efficiency. I need to be taking a look at alternative energies. When you define it as what's good for the community, it's different than saying, how do I produce electrons? And that way of thinking, I think, is part of the challenge we face as we try to navigate our way past this climate crisis. So, Kim, do I move on?
Yep.
Okay. That was the high level look. Climate science, how did we get to where we are? And let's take a look at Holland's community energy plan. Because just as we saw in the other discussion, climate science didn't fall out of the sky. It's been studied for a long time. Our community energy plan didn't fall out of the sky either. It did come up after a one-year study. It wasn't imposed on us by outside agitators. It arose organically from within the community. So let's take a look at it. going back to about, my screen is getting covered by other logos there. I think about 2002, I began hearing from my friends who were in engineering at Herman Miller that they were really working with this book, Cradle to Cradle. And the idea was beginning to percolate, at least in the business world, the manufacturing world, that the way we go about doing things may not be healthy for us all in the long run. Will McDonough was proposing this idea that manufacturers should look at the materials they use, the product they create, the end of the product, and what happens to that product when it can't be used anymore. His proposal was that it should be turned into new materials for new product. That's something that old products should not go to landfills. That's the cradle to cradle concept. He was saying, why not challenge the notion that human industry must invariably damage the natural world, which is what the manufacturing system has been doing. It doesn't have to be that way. And again, you hear John Muir in this conversation, you hear Aldo Leopold reflected in this conversation. The way we do things is impacting the natural world that we need to live in. Do we have to keep doing it that way? In 2002, I was hearing from my friends at Herman Miller, they were beginning to challenge that notion. 2004, a film called Kilowatt Hours was in circulation. This is actually the first time I met Don. Don had seen Kilowatt Hours, was impressed, bought copies, and was taking them around everywhere he could in the community in order to get people to watch the film and begin to ask the question, which was a moral question, what's our responsibility for the electricity we use? And that's the question that filmmaker Jeff Berry was asking. Most of us experience electricity as a switch on the wall. And all we want to do is just go to the switch, turn it on, and have the lights come on. But there is a whole world of activity behind that switch, and it's impacting people's lives, particularly in Appalachia, where mountains are being blown apart, people are being forced off ancestral lands, and toxic chemicals are being released into the river valleys in order to get coal to burn to create electricity. Barry wanted us all to recognize that we are part of the system that does that. And he says, my greatest hope is that you will take action after watching Kilowatt Hours. And so again, like we were seeing earlier, people looking at this energy climate scenario are beginning to say, if we can't live with what we're seeing, we need to take action. For the city of Holland in particular, the energy issue got really significant in 2006. That was the year that the Board of Public Works announced that the old James DeYoung coal-fired power plant was no longer viable. It couldn't be repaired, it couldn't be upgraded, there wasn't anything to do, it had reached the end of its life cycle. And in 2006, they announced their intention to build an even larger coal-fired power plant. Okay. In 2008, that discussion around the city was beginning to mature, and ad hoc groups were beginning to form and talk about the future of the city, future of the city's energy. There was a group called West. They called themselves Windmills on Every Church Steeple. That was sort of a graphic illustration of what they thought we could do other than coal. They sponsored a series of events called West Wednesdays and brought in speakers who began to educate the public about this issue. One of those speakers in 2009 was Mayor Al McGeehan, who told us that Holland has a good record of thinking and acting green. There has been a baseline community energy survey. City Council has a sustainability plan, discussed, that emphasizes housing energy efficiency. And so we're beginning to see this conversation move upward and in the community awareness grow. and action beginning to formulate. 2009, that conversation around the city led Mayor Kurt Dijkstra to then say we need to respond to that rising conversation, and they formed the Holland Community Sustainability Committee. And that committee was given the task of understanding what Holland's energy future ought to be. I was part of a group called the Community Energy Advisory Group, which was sort of the place where all these previous ad hoc groups came together and lobbied for an energy future in Holland. On the screen, you're seeing some of the materials that were produced back in 2010. The one on the right was kind of a 4-page folder that helped people understand the choices you could make between a coal-fired power plant and other options, and encouraging people to think through what options do we really want. Also in 2010, that Sustainability Committee engaged Garforth International to come to town and do a careful study of how we use energy in the city of Holland and make recommendations for how we could move forward. So they literally mapped the city and identified every building, how much energy it uses, where energy gets used the most, what kind of fuels are being used, and then developed 4 scenarios that the city might adopt in order to have a smaller carbon footprint. About the same time, the BPW was analyzing its pathway forward and asking themselves, what's the best thing for us to do? They ran a study they called P21, Power for the 21st Century. And notably within their analysis, they ramped up the conversation above just business plan, business model, technology. And they began to ask, what are the values of the community that need to be represented in our planning? They use something called SROI, Sustainable Return on Investment, to look at the financial, social, economic, environmental, and health impacts of several new generation options for the community. And engaged in that process on their track, combined with what was taking place elsewhere in the city, they ultimately made the decision to build the new Holland Energy Park, which is a combined cycle gas turbine plant. It is at least 50% more efficient than the old James DeYoung plant. Garforth presented a plan. The city accepted that plan, accepted the most aggressive scenario for carbon reduction, and then began to discuss how do we put that plan in place. So if we take a look at that plan and flip the cover, ask what's in there, you're going to find some of Garforth's work identifying where energy is being used. The darker colors here are the most intense uses of energy. And so in the city of Holland, our most intense uses of energy are Core City, just north of that, and then again, just north of that towards Windmill Island. The industrial area comes in again. Holland Heights gets off as probably the least use of energy. And what the study showed was over time, the dark color starts moving south as we anticipate between now and the study's 2050 finish line, more population, more industry. We can anticipate an intensification of our energy demands in those other sectors south of the core city. The study got a baseline for us. If you add up all the fuels used in the city, calculate how many tons of carbon dioxide are being produced by whatever happens in the city, and divide it by the population, you end up with 24 metric tons carbon dioxide equivalent per capita. That's where we were in 2010 when the study was done, and in 2011 when we accepted the study. If the study tells us that if we did nothing at all, we can expect that concentration level to go up. And by 2050, we would be at 36 metric tons per capita. We chose not to do that. We implemented a plan. And by 2020, we had reduced 24 down to 19. It appears that the plan, as it's moving along, its intention was to get to 10 by 2050. It appears that we're not going to make a lot of progress between now and 2030, and then gradually decline on our way to 2050 if we would continue the path we're on. And that's what's raising the question today. Does the community energy plan deliver what we need to have based on what science is telling us about the near future? The black line you see there would be what the Holland Climate Collaborative, which Don and I are a part of, is recommending. We're recommending a much steeper cut in our use of carbon fuels and a reduction in our carbon footprint. That we need to get cut where we are in half by 2010 and cut it in half again every year, every 10-year cycle, so that by the time we get to 2050, we can be down to zero. Global climate science is telling us we need to follow that pathway if we're going to avoid the worst impacts of climate change. All of that is kind of hard to imagine, so I created a picture for you. 19 metric tons of carbon dioxide equivalent per capita. How much is that? Well, Google tells me that an adult African bush elephant weighs 6,000 pounds. So those 19 metric tons are the equivalent of putting about 6 elephants into the air every year for every person in Holland. By weight, it's just a lot of stuff. And it gives you a sense for the magnitude of the issue we're trying to deal with. The community energy plan has a sort of strategy built into it. Energy efficiency is the first thing you want to pay attention to. The tagline there is, if you don't need it, don't use it. So if we can make buildings more efficient, industry more efficient, if we could take a look at our urban design and minimize the amount of miles people have to drive, we would then not need an equal amount of energy to do an equal amount of quality living. And so the thought is, if you don't need it, don't use it. Let's get in a position where we don't need to use as much by making efficiency gains. Heat recovery is kind of number 2 on the list. And the tagline was, if it's already there, use it. Holland has a brilliant example of that already in our snowmelt system. The end product of electricity production is hot water. We have a lot of hot water. Most communities take that hot water and run it through cooling towers to get rid of it. We take some of that now and run it through our snowmelt system and get more value from that so-called waste heat. The Garforth report is suggesting that we really use this kind of a resource even more than we do. Can we take that heat and use it to heat buildings? Could we replace boilers in furnaces in commercial buildings and in private homes and just supply the hot water that would heat the home? There are 20 million homes in Europe that already heat their home this way. They recover the heat from a power plant, use it in the city to heat buildings. So we've already paid for the heat. We've got the hot water. Let's wring a little more value out of it. The third thing in line is renewable energy. The tagline was, if it makes sense, go carbon free. So as we think about our future, when will be the right time to begin to incorporate more alternative energy into our portfolio? What I was suggesting to you earlier is this is the time. The price of carbon, of alternative energies has fallen close to 80% on photovoltaic cells over the last 10 years, and it's continuing to go down. The efficiencies of panels is continuing to go up. So in terms of finances and opportunity, it is never going to be a better time than right now to begin to make those kinds of transitions. And then the other piece in the strategy is energy distribution. Tagline is invest where it makes sense. And so we begin to think through all of the interactions in the community, urban design, use of cars, placement of stores, can people walk or bike to work? How do all these things interface in such a way as to be able to use less energy? That's an intense kind of discussion. It's going to be a difficult kind of discussion, but it is the next place we need to go. Holland needs to think of itself not as a city, but as a hub, because thousands of people move in and out of Holland every day. The plan had tools in it and suggestions for how to start. There were scale projects that suggested. One was industrial park integrated services. They suggested we should take the entire historical district, single family homes, and use them as a demonstration project for how to make houses more energy efficient. Suggested that we take a look at the Hope College campus as an entity and make it more energy efficient. That we should take a look at the high school, hospital, aquatic center as an energy unit and understand how to make it more energy efficient. The campus and the school, hospital, aquatic center are at either ends of town, and the suggestion was if we think of distributed energy, we could run a trunk line with that hot water between those two major uses and begin to use the hot water value in those areas and eventually pull off trunk lines into neighborhoods. And it suggested that we should take a look at an initial district heating network. How do we pull together the industrial area so that they are as efficient collectively as possible? And there were all sorts of tools. If you want to be able to pull off that sort of thing, you're going to need financial incentives, greenhouse gas emissions management, regional energy planning, any number of tools. So there were projects that should be considered tools that help make that come to pass. Coming near the end of my presentation here, the goal for the Holland Community Energy Plan is that Holland is committed to being a highly competitive, world-class community supported by innovative energy solutions that benefit the citizens, the business community, and the environment. The most important word to me there, folks, isn't energy or plan. The most important word to me is community. We want to be a place with a high quality of life. We know we can't accomplish that goal unless we face up to these issues related to energy. But the focus is not on the energy. The focus is on the community and how do we have a high quality of life. The original plan suggests that we get down to 10 metric tons per capita by 2050. I'm suggesting that's no longer a viable goal, but I don't want to confuse metrics with goals. Our goal is not to reduce carbon. Carbon is a metric that tells us whether or not we reached our goal. We have, I think, completed the first stage of this process. The Community Energy Plan is 10 years old. It's got us launched. We're headed in the right direction. But the second stage is going to need to break the gravity of conventional thinking. We need to fire the second stage of the rocket. And that's what I'm hoping that will happen now. You may know that the mayor has reactivated the strategic development team, which is a component of the Community Energy Plan. And their task is to understand how have we done compared to the plan's goals, what goals do we need to set, and what resources do we need in order to reach the new goals. There's a lot that needs to be covered there, but there's a lot that can be accomplished. For those of you who are history buffs in the lower left there, 1950, that's the launching from Cape Canaveral of the very first two-stage rocket. And I view with a certain amount of humor, the folks standing in the foreground there with their reel-to-reel cameras on tripods standing out in the open. And it's an indication of just how far we've come. But we made a decision. We wanted to get a job done. And look how it kind of changes that came about because we decided we were going to do it. I'm going to kind of skip that one. There are certain things we need to do if we're going to break this gravity. There are hurdles we have to get over. One is we're going to have to decide that we're thankful for electricity. It isn't your human right to have electricity. It's something we can be thankful for because it's enhanced our quality of life. But if we continue to just demand it as if it had to be delivered, we're going to have trouble making the necessary changes that need to be made. We're going to have to take a look at what's the purpose of the Holland Board of Public Works. Are we simply there to provide services, or are we there to provide this leadership in sustainability? That's a discussion that'll have to take place. And ultimately, we're each going to have to ask ourselves, are we responsible for the atmosphere? We do put those 6 elephants up there. Am I responsible for that? And if I am, what should I do? What's my moral responsibility? There are some practical governance kind of issues that we're going to have to deal with. The BPW has a service area that extends beyond the city out into the townships. Well, you have these different governance bodies with different expectations. How do you provide a uniform program that makes everybody happy? That's going to be a governmental governance kind of problem. The other wrinkle there is that the city of Holland owns the BPW. And in a certain sense, we can tell the BPW what to do. The townships for themselves don't have much to say about it. We own it. Again, how do we navigate these transitions across governmental and business lines in such a way as to create a healthy overall community? Those are kind of knotty problems that we're going to have to deal with in the long run. So trying to wrap it up here, back to what our goal is. We're hoping you learn enough that you become someone who can be an advocate, someone who can tell your stories. If you do not, it becomes questionable whether or not we can really get the future we would like to have. And so we've covered a number of things on the agenda here. Don will kind of be the leader on next Monday's call, taking a look at that second stage, the community energy plan, and then really focusing in on what can you do.
I had watched a message on chat, or I left one on chat. It was about the use of water more in the renewable source of energy. Is there any way to bring water into play anymore?
Water is, yeah, I'm not sure exactly how to answer that question. That water is one of the ways we can help water is, number one, if we don't use so much of it in power production and in manufacturing. And I know those are some of the most difficult places to minimize water use. Could you kind of fill out the question for me a little bit more?
Yeah, sorry, I don't see it in chat, Suzanne, so it must not have come through.
That's because I only made a chat to him, and that's why. Okay. I just thought perhaps there were ways more energy could be provided with the use of water somehow.
Yeah, a lot of the energy related to water is related to moving the water. I don't know if you ever lifted up a 5-gallon bucket, it's pretty heavy. It takes a lot of energy to move water. And so the degree to which we minimize our use of water would have a direct bearing on the amount of energy we do or don't use. So I would think in the long run, the energy efficiency appliances, the new washer dryers use a lot less water, for instance. If we take a look at the appliances we have at home, and can we minimize that use? I can only give you my personal thought. I think we need to take a look at watering grass. You know, we spend a lot of money to create potable water, and then we put it on the ground to water grass. That's expensive water. You know, it's expensive not only in financially, but in terms of energy. So could we take a look at landscaping things that are appealing and aesthetically pleasing that don't have to use that much water? It's a big issue for agriculture. Agriculture is probably the primary user of water in this country. And so can they get more to drip irrigation, those sorts of uses that minimize use of water?
Okay, thank you.
Okay.
Peter, I'd like, this is Don, I'd like to jump in with a little bit of a homework assignment, if people are willing, as I look forward to next week's class. So my story next week is pretty simple. I think Peter has laid out that we have a climate crisis, and he's indicated that we actually have solutions, and we'll talk a little more about that next week. But if we have a climate crisis and we have a solution, what's the problem? And the problem, one of the problems, the big problem I see, is to create the political will to implement the solution. Our local decision makers have to make some decisions. And my reading of the situation, you may want to offer a different perspective, is they're understandably nervous about making decisions. They're understandably nervous that the people won't support them in making these decisions. Politicians represent us. They do, hopefully, what their constituents want them to do. And I think there's a myth out there that people in Holland don't care about climate change. As long as that myth exists in the minds of our local decision makers, they're not going to feel empowered to make the decisions we need them to make. So the homework assignment is simply this. I hope to talk very little next week and listen mostly to you tell your stories as a practice for telling them to our local decision makers. They need to hear from you, not about scientific studies you've read or data you have. They need to hear from you that you personally care about climate change. And so I urge you to think of two kinds of stories that you could share next week. One, something about how you or people you know and love are affected by climate change right now. Example, I have a son and a daughter-in-law and two wonderful grandchildren who live in Santa Cruz, California, and they're spending their time dodging the wildfires right now. Maybe you have other kinds of stories of people you know and love who are affected in one way or another by climate change. The second is, it seems to me that every day I see important stories about climate change in the media, in the newspapers I read, in the TV shows I watch. And somehow those stories come every day, but they don't seem to be about us, and I think they are. So maybe you could make note of a particular story you saw in the media recently that caught your attention about climate change. So if enough people have those kinds of stories to share next week, I won't have to talk at all. That would be wonderful.
Thanks, Don. Anyone else have questions or comments they want to make before we close the meeting?
That was fabulous.
Thank you.
Awesome. Okay, lots to think about, my friends. We look forward to seeing you next week. Thanks for being with us this afternoon to kick off our start of fall. It's great to see you all, and we'll see you next week. Thanks, Peter. Thanks, Don.
Hey, could I ask a question?
Oh, yep, go ahead.
Sorry. I just typed it in, but I don't know if that comes through or not.
Oh, okay, hold on. Who is this?
This
Oh,
is
Jim. Hi, Jim. Yep.
Yeah, all this is great, and I think it's very important, and it's what we should do. But the frustration that sad to say, always comes into my mind is that we could be the perfect community in this regard. But if the county doesn't follow suit, the state doesn't follow suit, the country doesn't follow suit, and the world doesn't follow suit, what difference does it make to our collective futures? You know what I'm saying?
Mhm.
You know, it's the right thing to do, but is it really going to change the long-term outlook we have for the planet?
Just a quick comment. My mother always used to say to me, just because everybody else was jumping off the bridge, would you do that too? It is a conundrum, but it can't keep us from doing what we're responsible to do.
I could add too, I think Don and I had the same mother, because I heard the same story.
Me too.
But I would point out that the original Community Energy Plan from 2011 was not written as a climate change document. It was not written as a environmental document. It pointed out that there were great benefits for the environment and great benefits for climate in doing what the report called for, but it was essentially a business model plan. And it pointed out very acutely that communities that fail to address energy efficiency fall behind. Industry grades itself by how efficient they are. How many units of energy does it take to produce a product? And whoever wins that battle wins the business.
Mm.
And so in a certain sense, what the rest of the world does is awfully critical, but it's also the case that we aren't going to win the immediate battle either unless we pay attention to this issue. It is vitally tied to our business success.
Everybody wants to follow a success. If we do the right thing, we can inspire other people to follow as well.
Martin Luther, right? Martin Luther King, who said it's always the right time to do the right thing.
Yes, it is.
Sure.
Lots of opportunities for that right now in lots of places. This was so great. Thank you all so much.
See you next week.
Okay, bye everybody.